Hi everybody. This presentation is about spatial data model. At the end of this video, you should be able to understand the dimensions of geographic data, spatial data types, the advantage and disadvantage of raster versus vector model. Basically, if you take any of the data structure, it does not have a spatial information. But geographical database model will have a spatial information in addition to the data that we are going to store. So this information is what we call it as the topological information or the relationship among the features. So spatial data model is going to be used in several GIS database models such as raster model, vector model. So to understand the dimension of geographic data, any data, if you take, it has three modes or dimensions: spatial, thematic, and temporal dimensions. Let us consider an example. A petrol bunk at 20 Patel Road works with a capacity of 3 filling points and 15 staff members. The spatial dimension for this example includes the location based information. So in this example, the petrol bunk is located at 20 Patel Road. It describes the positional information of the place over the earth. Though it is in a textual form, that is the location information. However, in GIS, it is necessary to represent this location in a geographically referenced data layer, that is the map. So with reference to GIS, spatial data is considered as a location based information. So in this example, the address of the petrol bunk is the location information. Next is the thematic dimension. The thematic dimension describes the characteristics of the spatial data. The spatial information is about the petrol bunk. The characteristics of the petrol bunk is the capacity of the petrol bunk, that is 3 filling points and 15 staff members. So that is the attribute information or the non-spatial information. So that is about the thematic information. If you look at the temporal dimension, this actually refers to the data, the time at which the data has been collected. So to explain you that, I'm going for another example for temporal dimension. Let us consider an example. In this example, temperature at 22 degrees north and 88 degrees east was 35 degrees Celsius. In this example, location information is given, but the temporal dimension is not available. So how this example should be actually, the complete form of this example should be: temperature at 22 degree north, 88 degree east was 35 degree Celsius on 15th May 2005 at 12 noon. This example contains all dimensions. The spatial information is the location of the temperature record, and the thematic information is the theme that is getting conveyed is the temperature, and the temporal information is given in terms of the date and time. So basically the dimension of geographic data has three: spatial, thematic, and temporal. To summarize, the spatial dimension of the geographic data is the location based data, thematic data is the characteristics of the spatial data, and temporal data is the time at which the data has been collected. So this is the dimension of a geographic data. Now let us look at the spatial data types. So in GIS, if you take the spatial data types, there are two basic types. One is called as the vector data type, other one is called as the raster data type. Now we try to understand what is this vector data and raster data. Vector data. Basically, we want to represent the real world features in the GIS environment. What is this vector data format? A vector data or a vector feature has its shape represented using a geometry. And the geometry is made up of one or more interconnected vertices, and the vertex describes a position in space using x and y coordinates, and sometimes it will also have the z dimension. So x and y will give you the location, and z will give you the third dimension of that particular object. So in the vector data model, all the features of the earth are represented either as points or lines or polygons, which is also called as the regions. And the high level objects in the vector data format are the TINs, which is the triangulated irregular networks. If you look at the vector data, how the data is getting recorded or what is the interaction that is being taking place is, it is based on the interaction between arcs and nodes that is going to represent the points, lines and polygons. For instance, a point, it is a single node. So these are all the points which is considered as a single node. And if you take a line, the line has two nodes and that is connected by an arc between them. So the lines are connected by an arc between two nodes. If you take a polygon, it is a closed group of three or more arcs. So this is basically the vector data format. Either it may be a point or it will be a line or it will be a polygon. So with these three elements, it is possible to record most all necessary information, that is converting the real-time environmental features into the GIS format. These are all the three entities by which you try to convert it as a vector data format. Now, what this vector data is good at? Vector data are good at this points, lines and polygons can be used to represent the true shape and size of the object that we are looking into the earth, and this is also going to represent the non-continuous data at a very good way. For example, the rivers, the political boundaries, road lines, mountain peaks. Rivers is given by a line, political boundaries are given by a line, road lines again a linear feature can able to represent the vector data. And this is going to create an aesthetically pleasing map because it's going to have point, line and polygon, and every feature is converted as point, line and polygon. And this is not going to occupy a lot of disk space because it is going to occupy only the XY locations of the nodes and the arcs. So only that information is saved in your computer. So there is no it is going to conserve disk space. So basically, if you look at the real-time feature like this, how the vector data will be is the blue line represents the line data and all the red dots indicates the point data and the white indicates the polygon data. So this is about the vector data. Now let us look at the raster data. Raster data is basically a cell-based data such as what we have already known as an aerial imagery or a digital elevation model. Every information is stored in the form of a cell. This is characterized by pixel values. Every pixel is going to take some values, and this is going to have a very big table, and each pixel is going to have an assigned value that will be from 0 to 255, which represents the gray levels. And the meaning behind these values is specified by the user. What is the value that the pixel is going to take? That is given to the user. User can say what is this pixel is going to have. For example, it can be a digital elevation model in which all the pixels are going to take the elevation data, and I can also have a temperature values of the pixels, and with reference to hydrology, it can be a rainfall information, it can be an evaporation information, it can be evapotranspiration information that the pixel is going to take. Like vector data, raster data are also good at certain things. This is very good at representing the continuous data, for example, the slopes, the elevations. So raster data is very good at representing the continuous data, and the multiple feature types can be represented like points, lines and polygons as a single feature types in the cells. And the rapid computations is possible in a raster format, and all the mathematical expressions is possible uh, through this raster data. Map algebra is possible. An analysis of multi-layer or multivariate data, that is satellite image processing and analysis, can also be done because it is also representing the raster format. And this is going to occupy a lot of disk space because every pixel information has to be saved at the computer in the form of a tables. That's why it is going to occupy a lot of disk space. And what are the advantages and disadvantages of raster and vector model? First, we'll look at the raster model. The advantage of raster model is this is basically a simple data structure because the entire area is going to be converted in the form of a pixels. It's going to have number of rows and columns, and every pixel is going to have one information. If you take rainfall, it is going to have rainfall. If it is going to be a digital elevation model, only one information is available. So this is good at representing one feature at a time. So it is having a very simple structure with reference to rows and columns, and this is easy and efficient overlaying is possible with the help of a raster model because everything is in the form of a pixel is going to contain a value which can be converted in the form of a matrix, and matrix algebras are very easy, and it is the one of the advantage of a raster model. And compatibility with remote sensing imagery, this data model is very good compatible with the remote sensing imageries, because remote sensing imageries is also going to have a pixel based information, and high spatial variability is efficiently represented. Continuous information can be represented using the pixel data, and efficient to represent continuous data. That's what. And the disadvantage of the raster model is it is going to occupy large file size, and all objects or pixels has no discrete objects. Every information is given in the form of a pixel, and you cannot separate any objects out of it. And difficult to build topological relationship. What is the relationship between one point information to another point information? That topological relationships, it is very difficult to build in the form of a raster model, and this is very inefficient in projection transformation. And now we look at the vector model. The advantage of looking at a vector model is, as it is not going to have the pixels, it is going to only in the form of points, lines and polygons. The size that is getting occupied in the computer is very small, and the individual identity for discrete objects like lines, polygons, etc. is very good at vector model, and efficient for topological relationship. The relationship among the features, the relationship among any 2 points within the map can be easily derived through the vector model, and the map output is also going to be very pleasing, and it is going to be very accurate, and it is very easy to edit. And the disadvantage of a vector model is it is a complex data structure, and it is difficult in overlay operations. Like raster model, this cannot be easily overlaid, and it is not compatible with remote sensing imageries, and it is not suitable to represent the continuous data. So if you look at the comparison between raster and vector data model, what is good at raster is not good at vector, and what is good at vector is not good at raster. When to use raster model and when to use vector model, it all depends on the purpose in which you are working with the GIS and what kind of an analysis that you want to do it further. So in summary, the spatial data model, we can say the knowledge about the data models of GIS is important because it provides us information on how the data are stored on computer and the representations. Depending on the spatial data types, either it may be raster or vector, the procedure of analysis differs and the result obtained will also be different. So that is all about the spatial data model. The next lecture is on spatial data structures, which will be posted soon.